Hi, today we'll be working on a C program. We'll be working on recursion. So recursion, it's a hard topic in programming. Probably the hardest topic there is, to be honest. Don't be afraid. It can be learned with some practice. So the way I learned it was just to kind of like write it down on paper. So what happens is recursion is a process of repeating a function call from itself. So a function calls itself in the function. So it's kind of tricky. It's hard to debug because the debugger doesn't really show the different calls. It just shows the same call and then it changes to another call. So, and then when you exit the calls that already happened, it doesn't show you the change and how many calls you're in or out. So they haven't really developed IDEs for recursion yet, at least the ones that I use, like JetBrains or Visual Studio Code, or like the other ones. I forgot what that other one's called for Java, but for C it's pretty much just Visual Studio Code. And then now JetBrains has C-Line, and then I think Atom 1 has a compiler too, or an IDE. So we'll just work with the example and then we'll try to debug it. So we'll just say hashtag include and then stdio.h. So we'll have a function here at the top. Let's call it int factorial. We'll pass an unsigned int. Unsigned is a type. So unsigned, I believe it can be a negative or positive integer. Actually, no, sorry, I apologize. So an unsigned integer is a 32-bit integer that's non-negative, so the values are between 0 and some big number like 4 billion or something, more than that. Maybe 42 billion or 4 billion. So it is unsigned means positive only, so signed can be negative or positive, so I'll just write that out. I don't really use those, to be honest. I kind of just use the general types that are common to all programming languages. So we'll just write here unsigned is a positive integer. And then we'll just say signed is negative and positive. So signed goes from like negative 2 billion, negative maybe 2 billion or 200 million. So some large number to the same positive number. So we have int factorial takes an unsigned int I, and we'll just open those brackets here. And we'll say if I is less than or equal to 1, return 1. And I guess this is the else. So otherwise, without an else, so return I times factorial of I minus 1. So factorial is the method that we just created. So if I is less than or equal to 1, we'll return 1. Otherwise, we'll return I times factorial, passing in I minus 1. So we're going to call the function that we called. So it's a function call within itself, right? So that's recursion. So that's the recursive part. So it's calling I times factorial. So whatever I is, so it's going to get this value first. We're going to get this value first, factorial I minus 1. We're going to pass in I right here, minus 1. Then once we get that value, since it returns an int, we're going to multiply it by I. So that should be all. Then we'll do the main function underneath. Notice that we didn't need to prototype because we had the other function first. If we have main first as the first function, then we need to have a prototype, I believe. So once again, if we had like a main here, the main function was here, and this was below, then we would have to prototype it here. Like prototypes, we have to call the function with the types with the semicolon, I think. But since we defined this one first, then we don't need to prototype it. So we have main, int I points to 15, and we'll say printf factorial of %d modifier is %d modifier. So we're going to pass some values here. New line, then comma, and then I will pass in I and factorial. Oh, whoops, I need another comma here. Remember to separate your modifiers that you're passing in with a comma too after the string. So we'll pass in factorial of I, factorial of I, or we're going to print that out. Then at the end we'll just return 0. Control S to save. So, well, if you're on Mac or Linux, maybe Control S for Linux too. Or if you're actually running in the VI editor, then it's like Shift semicolon W, I think. So now we will just we'll set some breakpoints here. So we'll set one there, set one here. Then we'll click the debug icon in the top right corner. When I did this, when I learned recursion, I remember the debugger not working, not showing me the step. I think is it steps? No. There's a word for it. Pass. I think it's called pass. So each recursive pass, you could have multiple levels. Like in data structures, there was recursive passes, I swear, with like 30 levels or more. And I just write them on paper. And at each pass I had to kind of like write it underneath, indented. That seemed like the only way to do it because the debugger doesn't tell you what pass you're on. So once you start exiting the passes back from 30 to 29 to 28 all the way back to 0, it doesn't say which pass it is. So it's really confusing. This is probably an easier one, but you could see like massive codes with recursion, like thousands of lines. Like tens of thousands of lines with recursion, or at least 1,000 lines. And you won't see the passes. Like it's just gonna be the same thing every time. It's not gonna tell you what it is. You're just gonna see your variables changing, and it's not gonna tell you what pass you're on. So it's, unless you write it out, it's probably like, unless you have like some crazy memory, it's hard to know what pass you're on. So anyways, we'll just we pass. Okay, so we're here. We're in the main function. We're starting in the main function. Remember, the code always starts in the main function. So we have int I points to 15. We'll step over the I points to 15. You can see it in the local variables. I feel like I'm missing something here. Oh no, okay, we're going to call factorial of I. So what's going to happen in this print statement is we're going to call factorial and pass in I as its parameter. So it's going to pass in 15. So it's going to take the unsigned int is going to be 15 in this case. 15 is not going to be less than 1. Then it's going to jump to this recursive call. So here we'll step in. So you can see I is 15, right? Let me just zoom out here. Okay, so I was, we executed this line here, printf factorial of %d is %d new line. So what happened is we jumped into this factorial function call. Think of an imaginary arrow going right up here, right? Then we're now in this, we're still in this call. We've dived into this method now. So the arrow's here. We went right to this function call. We passed in 15 when we called. I was 15 when we entered this function call. So now it's saying if 15 is less than or equal to 1. So is 15 less than or equal to 1? It's not. This line will get skipped to return I times factorial. So I is 15. So times factorial. So ignore this part. Ignore what I is at this point for a sec. We have to solve this part first. Factorial of I minus 1. Once we get that return value, then we can multiply it by I. So there's only like, actually there might be a few passes here. So we're going to jump into the factorial recursive call. I is 15 minus 1. So it's going to go, so it's going to say call factorial. The computer is going to say call factorial of I minus 1. We're going to substitute 15 for I. So call factorial of 15 minus 1, so call factorial of 14. So step in. There you go, 14. So we jumped up here. What happened in that process is when we call the recursive part, we jumped right up to this method again. We passed in 14 for this right here, for the parameter. Enter this bracket, came down here to if 14 is less than or equal to 1. So this is our first pass. We didn't have a bunch of values to kind of keep track of. You can write it down what I is and what pass you're on if you want. In a notepad it works too. Yeah, honestly I just did it in Notepad, to be honest. I think once I started getting into complicated data structures, I just used the notepad, like the computer notepad, to write in the passes. This is an easier example, so if you want you can just write first pass in the comment. I was 14. So if I is less than or equal to 1. So if 14 is less than or equal to 1, so is 14 less than or equal to 1? It's not. So this line will get skipped again to this line. So return I times factorial of, okay, yeah, so that what happened in that original pass is I had a value, and at this point we have no idea what it is, because look, our variables are just showing 14. It's not telling us what I was like 1 or 2 times ago, right? So that's what you kind of need to write down on your passes. So before you entered your first recursive call, what was I? And then when we enter it again, all the values changing, and you can kind of like indent them, because once we exit the pass, it's going to be kind of going back up to its indents, back to the first one. So it's kind of confusing. So anyways, it's going to call I times factorial of I minus 1. What's going to happen is when we revert those passes, right, think of like this, like see the mouse, it's going to go like, when we go our first pass, it's going to go like that. Second pass is going to go like that, like to the right. Third pass, fourth pass. Imagine when we go back up, it's going to backtrack where it was, to third pass, to second pass, to first pass. And each of those passes, you need to know what I is to calculate that value. And it's not going to tell you. Well, the computer will know, but you're not going to know, right? So you need to keep track of it. So at least you know why I is changing when we go back. So anyways, at this point we just have factorial of 14, because I is 14, minus 1. So now we're going to step into its, I think, is this the second pass? So whatever number it is, it's going to call this function again and pass in factorial of 14 minus 1. So it's going to jump back in and it's going to pass in 13. So we stepped up here to the function, right? Then we went down to the bracket, went down again to this line, entered the function with the parameter of 13. It's going to check if I is less than or equal to 1. So is 13 less than or equal to 1? It's not, right? So 13 is not less than or equal to 1, so this line will get skipped. We step into the next recursive call, and that's going to continue. So maybe let's just stop this for a sec. We'll change I to like 2. Actually, no, let's change it to 3, because it has to be. That'll give us like 2 or 3 passes. So we'll run it again. So I is equal to 3, we step in, printf. Okay, so we're going to jump into our first recursive call. So you could note, maybe we could try to note it here. I haven't done this in a while, so we'll just say first pass I is equal to 3. So first pass I is equal to 3. I think that's all we really need. I forgot how I did it. I just kind of did it like without thinking. It seems like that's all we need, so we'll just step in. So we can just remember to indent the second time so we know which way to go back up. It's kind of like a ladder, like a diagonal ladder. You go down and then you come back up. So that's kind of what's happening. Sometimes you can have a pass in a pass, so that's like advanced recursion. So like if we get down to this level, let's say we're like 4 or 5 levels down, and it has a recursive call in its 5th pass from like another recursive call. So it's like you start getting like multiple ladders everywhere. That's when you really need to write it out. I've seen some really tricky problems that literally take hours to figure out. Because imagine messing up in the middle and you're like, oh, I don't know where I am now. So you need to do it. It takes hours, but once you get it, it's like, oh, it's kind of hard, but it's cool. So we're in our first pass. We have I is equal to 3. So in factorial, we're passing in I is equal to 3 here. Stepping in if I is less than or equal to 1. So if 3 is less than or equal to 1. Is 3 less than or equal to 1? It's not, so then we write 3 is not less than or equal to 1. So this line will get skipped and we'll start at this line. So return I times factorial of I minus 1. So this is kind of where you need to somehow link this together. Because when we step back out of our first pass, I will be equal to 3, so hopefully we can know that that was our first pass. So we'll have to say 3 times whatever we got back for this. So now we'll be doing our second pass, so factorial of I minus 1 should be 2. So we'll say second pass, I is equal to 2. Jump back up to the function call, passed in 2 for this value, for this parameter value. It's going to check the condition again if I is less than or equal to 1. So is 2 less than or equal to 1? It's not. This line will get skipped again. We'll start at this line. Return I times factorial of I minus 1. So factorial is, I is currently 2, so it'll be factorial of 2 minus 1, which is 1. So we'll say our third pass, I is equal to 1. Oops. Yeah, this isn't a recursive method that like has recursive calls in recursive calls. So if we do see this isn't a data structures series, since we've kind of already did them, and they're pretty much similar. I think we have done recursion before. We must have. Or I think you'll be seeing, if I haven't posted them yet, with the trees. Trees get really recursive, so we'll be working on that. You'll see some recursive calls in recursive calls, and I'll post those soon. So we have third pass I is equal to 1. So third pass I is equal to 1. So we have if I is less than, so if is 1 less than or equal to 1. 1 is less than or equal to 1. So now we'll return 1 for the third pass. I think that's what's going to happen here. So return 1 for our third pass. Then it's going to jump back to this line, I think. And then you're going to be like, well, why are we at this line? Because it's kind of like where were we before that recursive, before the recursion started. So at this point we're going to return 1, so you'll see what's going to happen. So we're going to return 1 for, I think, for the third pass. So step in. Okay, so it's going to, we'll just say we return 1. So it exits the loop. Okay, so this is for 2. Okay, so return 1 for our third pass. Now so now what's going to happen is we're going to go to our second pass and pass in. We're going to carry that 1 here. Return. So return 1 for the third pass. And then once we exited the third pass, we're going to return I times factorial so we had factorial of I minus 1. That's going to return us a value. We're going to multiply that by I. So we should be multiplying. Okay, so that third pass, right? Sorry to confuse anyone. So that third pass returned a value for this function call. I think that's we return 1 for that function call, right? So now it's telling us I was return 1 for this function call. For that third one, we didn't get down here. For that third function, for that third pass, we went up to here. We didn't get down there, right? So now imagine us stepping back up the ladder to that second pass where this line was executed. Return I times factorial of I minus 1, and for that third pass we return 1, so now it should be 2 times 1. There we go, 2. So hopefully you guys understand what's happening. See what I mean is confusing without writing it out? You have no idea what's happening. So at this point, we're going back to the first pass. So we should be at the first pass. So now we're at the first pass, I is equal to 3. We return 2 for this. So we return 2 for that. We calculated that we return 1. Sorry, 1 for this and times 2 for I. Then that line got executed. Then we reverted back up the ladder. Back to this. We're now at the first pass. So hopefully you guys understand why we're at the first pass. Because remember when we jumped into the recursion, we executed this line. Now we're jumping back out. So we're saying, okay, well, I is 3. And for this recursive call, we return 2. So we returned. So we went back to this line. We had I was 3. Then we returned, for that factorial, we returned 2. Because when we exited that line, we had 2. We returned 2, right? We had I was 3. So it should be, yeah, so it should have been, return 2 should have been 6. I don't think it might not print them all out like that. Because it's only going to print that last one. So hopefully we can see what we get printed out. It can be a little confusing, but hopefully you guys understand. Okay, yeah, so we were correct. It was 6, so hopefully you guys understand why it was 6. I was kind of, I kind of thought I lost track there too, but it was 6. So what happened was, sorry, you can see the external window. In your external window, you should be able to see that it was 6. So what happened was, we returned 2 for that last recursive call. So for this whole thing, we returned 2, and I was outstanding at 3. So it just went 3 times whatever this return was 2. This whole function just returned 2 after the recursive calls. Then we had outstanding 3. I was 3 times 2. I just took the value straight up, whatever factorial was. We returned 2. So it just went 3 times 2, return that value, and then it printed it out. The print statement's a little confusing because it's like a recursive print statement. But it went factorial of I was 3 is, I guess the last one was 6. So return 6 to the last one. So hopefully guys you understand recursion. That's kind of like, that's the base of it, pretty much. There, you'll see if you look at the Java data structure videos that I'm going to post, there are going to be some recursive passes that are like 15 passes with like another 5 to 10 inner passes. So you guys will check that out. Yeah, you guys should check that out if you're still if you need to learn more in-depth recursion. That's like the basic kind of way that it works. Just remember to write it out so you don't get confused. You can like indent them like that or whatever, and then so you just step down and then you step back up. So when you first start, you step down, right? You go down, then on the way back you go back up. So that's hopefully you guys, that'll help you guys. So if you guys want to see more programming videos on different languages or any coding or investing stuff, you guys can subscribe to the channel, give it a thumbs up, and I'll see you guys next time. Thanks.